A sentence can be remembered without its logic. The right terms appear in the right order. A definition can be repeated. A conclusion can be named. Then one small question changes the task. Why does that conclusion follow? The remembered sentence no longer carries enough weight. You need the relationship beneath it. This gap appears often because books, tutorials, and worked examples present finished explanations. While the connection remains visible, you can follow it without constructing it. Self-explanation briefly changes that arrangement. Instead of asking only what the source said, it asks why one part follows from another, how the example embodies the principle, or when the explanation would stop working. Suppose a course says that a larger sample can reduce uncertainty in an estimate. A learner repeats, because the sample is larger. The words are related to the claim, but the explanation moves in a circle. A more useful answer identifies a relationship. A larger sample can make an estimate less sensitive to unusual observations in a small set, while not removing bias from a poor sampling process. That answer contains a mechanism and a boundary that can be checked. Bisra and colleagues published a 2018 meta-analysis of induced self-explanation. Across varied tasks and instructional conditions, self-explanation prompts showed a positive average effect. The included work covered problem-solving, worked problems, and text study. That breadth is useful, but it does not prove that any request to talk longer improves learning. Prompt design, prior knowledge, task, and the accuracy of the resulting explanation still matter. Self-explanation is narrower than summary. A summary can list what happened. Explanation reconstructs a relationship. In a worked example, a summary says an estimate changed. An explanation identifies which assumption changed, why that assumption affected the result, and what evidence would have left the original estimate intact. The free 7-day recall experiment is linked below. It begins with access. This episode adds a different test. Can you reconstruct the link, not merely the sentence? Use explain, compare, correct. First, hide the finished explanation and ask one specific connection question. Why does this step follow? How does the example fit the rule? Which assumption makes the result possible? When would the explanation fail? Second, compare your answer with the source or worked solution. Identify the exact relationship you captured, missed, or changed. Third, correct the link in one accurate sentence. Do not reproduce the entire passage. Imagine learning why adding people to a late project can delay it further. Your first explanation says only that coordination becomes difficult. The source adds two relationships. Existing team members must transfer context, and additional communication paths can increase coordination demands. The correction need not repeat a whole chapter. It must connect added capacity with the temporary costs that can offset it. Better prompts reveal structure. Explain this is often too broad. You can respond by paraphrasing the heading or saying everything you remember. A useful prompt points toward causality, contrast, condition, or boundary. What changed between these cases? Asks for a contrast. Which assumption makes this result possible? Asks for a condition. When would this explanation fail? Asks for a boundary. Keep the explanation at the right level. At the shallow end, you replace the claim with a synonym. At the ambitious end, you explain an entire system before understanding its parts and produce a polished mixture of memory and guesswork. The useful level is one connection above description. Explain why one step follows, why one example fits, or which feature separates one case from its nearest alternative. Prior knowledge can help and mislead. It supplies connections that make a new idea easier to integrate, but it can also force new evidence into an old model. When the two conflict, explain the exact point of conflict. Which assumption changed? Which cases does the old model still handle? Which new condition requires revision? That is more informative than replacing one finished slogan with another. The check is essential. A fluent explanation can contain a confident misconception. Teach it to someone else may encourage clarity, but an imaginary audience does not verify the mechanism. Use the source, a worked solution, qualified feedback, or multiple authoritative references when the domain is contested or changing. Explanation can be silent, spoken, or written. Writing helps when the relationship has several parts, but the method does not require a polished document. Its essential feature is generating a checkable connection before seeing the finished connection again. Stop when the answer contains the necessary mechanism and boundary. Extra language can hide rather than improve the structure. Self-explanation does not replace instruction, real performance, or transfer practice. A learner with too little knowledge may need a clear example first. A safety procedure still requires the authoritative procedure and any required supervision. Explanation can clarify why a step exists. It cannot authorize improvisation. A new case may also contain features that the original explanation never addressed. Do not reward length, fluency, or difficulty by themselves. A hesitant but accurate sentence is more useful than a confident paragraph that changes the mechanism. If the answer is circular, replace the repeated label with a causal or conditional link. If it invents unsupported causality, return to what the evidence actually says. For the complete system and its evidence boundaries, see the evidence-based learner. If you can repeat the words but cannot explain why the step follows, you have not failed. You have located the next learning task. Generate one checkable relationship, compare it, and correct the exact link.